students, in this video we are going to study the concept of equivalent values when we are using compound interest. For understand the concept, we need to study the concept of the time value of money. Because money has the ability to earn interest, an amount of money have different values at a different point in time. Assume, for example, that the interest or the nominal rate of interest is 6%. So the money is worth 6%. And this 6% compounds annually. So it compounds once per year. And we have, in whatever point of time, let's represent the time with the line. And in whatever point of time, we have an amount of money, let's say $100. This $100 will have a different values later in time. For example, 1 year later, this amount of money will have earned interest. And this interest will be 6% in 1 year. So 1 year later, the value of this money that day will be $106. And the same, if we go backward in time, if we compute 1 year before or 1 year ago, what was the value of this $100? Let's, for example, if this is assume, for example, that this is a debt that you owe $100 and it's scheduled to be paid in this moment. If you pay 1 year earlier, for sure you're going to get a discount. If money is worth 6%, you will need to pay a lower amount of money that date. So you compute the value of this 100 1 year before, and that will give you a discounted amount of 94.34. So if we move forward in time, we compute the future value. And obviously, for computing the future value, we use the formula of future value. S equal P 1 plus I to the power N. In this case, N is 1 because it's 1 year and it compounds annually. So there is one compound period between this value 100 and the point in time in which I compute the value of the money. So in this case will be 100 times 1 plus 0.06 to the power 1. That gives me the 106 that I have here. And the same, at the other side, if we move backward in time, we compute the present value. And the formula of present value will be P equal S 1 plus I to the power negative N. And this, in this case, the future value will be this $100. So it will be 101 plus 0.06 to the power negative 1. So this value 94.34 results from computing this present value using this $100 as a future value. If you notice, these two formulas are almost the same, so we can think that if we move forward in time, we use a positive exponent, and if we move backward, we use a negative exponent. Now, let's see what happens if we have two different amounts of money in different points in time. When sum of money fall due or are payable at different times, they are not directly comparable. For example, these two amounts, $100 and 106. If we just see the two amounts, we don't know which one is greater than the other. Taking into account the time, of course, and taking into account the interest that they are earning. For making this sum of money comparable, a comparison date or a focal date must be chosen. So if we want to compare these two amounts, for example, we need to choose one point in time as a focal date. And for example, if we choose this point in time, 1 year before, and if we choose this, then for computing we can compute the value of these two amounts that day. So we need to choose a focal date. And after we choose the focal date, we are going to compute the value of each of the amount that we have that focal date. For example, we need to compute the value of this 106, this focal date. And obviously, if we compute this value that day, we need to move backward in time. And we have 2 years here, so the number of periods is 2. And because we are moving backward in time, we need to compute the present value of this 106. So for the value of this 106 that day, I'm going to use the formula of present value. So it will be 106 and then 1 plus I to the power negative 2. And this is, if we use the calculator, this is 94.34. Then I'm going to use the same with the other amount. So I'm going to compute what will be the value of this amount that focal date. And of course, to go to the focal date, I will need to move backward in time. So again, I'm going to compute the value here, and of course, I will need to use the formula of present value. So to compute the value for the 100, I will be using 100 and use the present value formula. So it will be 101 plus 0.06 to the power negative 1. Observe that to find the exponent that we need to use, we will need to know how long is the time between that amount that I'm using and the focal date. And we know that in this case is 1 year and the interest compounds annually, so there will be only one interest period, and for that reason this will be negative 1. If we do that, we notice that again we compute 94.34. After I see that these two amounts are the same, we conclude that these two amounts, 106 due that moment, is equivalent to this 100 due that day. So these two amounts are equivalent because they produce the same value when they are evaluated at the same date, at this focal date. And whatever focal date that we use, the conclusion will be the same. For example, if instead of using this point, I use this point here in the middle, 1.5 years after this $100, this will be our focal date, and we compute the value of this. Obviously, if this is one half a year, the other part between this focal date and 106 will be also 1/2 of a year. So this will be our focal date, and for computing the value of this 106, that focal date, so what we'll need to do is move backward in time. So I'm going to use the formula of present value with a negative exponent and use this 106. So the value for this 106 at that focal date will be equal to 106 is the principal, and multiplied by 1 plus 0.06 to the power negative 1/2. And negative 1/2 because there is 1/2 of a period between the date when the 106 was due and the focal date. So if I compute this, the answer is 102.96. Use your calculator for do that. We can do the same with the 100. If we do the same of the 100, computing the value of this 100 that focal date, then we need to move forward in time. And if we move forward in time, we need to compute the future value formula. We are going to use the future value formula. And obviously, the number of periods will be 1/2 of a period. So for the value of the 100 will be equal to 100 times 1 plus 0.06 to the power 1/2. And if you do it, the answer is again the same number. So the conclusion is the same. The two amounts are equivalent. So we conclude that any point in time may be chosen as the focal date. The choice does not affect the conclusions taken. If we conclude that they are equivalent, so whatever focal date will give me the same conclusion. And obviously the best way is to choose the easier focal date. And my advice is that choose one focal date in which one of these two amounts happens. For example, we can choose the moment when the 106 happened as a focal date. So if we use this point as a focal date, then for computing the value of the 106, we need to take into account the time between the moment in which this 106 is due and that focal date. But if you see this, there is no time between them. Yes, it's the same. The focal date is the same moment when the 106 is due. So there is no time. The n equals 0. If you want to compute using the formula, you can use the value for the 106 equal 106, 1 plus 0.06, that is the periodic rate of interest, to the power 0. But any number to the power 0 is 1, so it's 106 times 1. This is 106. So the value of this 106 is 106. And that's the reason why it's good to have the focal date in one point when one of the amounts happens. Because you don't need to do anything. You don't need to do this. Yes, you can type 106. The value of this 106 is 106. And that's it. So actually you don't need to do anything to compute this. However, if you want to compute the value of this $100, then you need to take into account that you need to go forward in time. And if you go forward in time, you will need to compute the future value. And so for this 100 will be equal 100, 1 plus 0.06 to the power 1. So let's type it here, and this is of course 106. Then you get the same conclusion, you get the same amount, and the conclusion is again, these two amounts are equivalent. To compare amounts, it's convenient then to choose as a focal date the date in which one of the amounts happens. Okay, so let's solve some problems of applications of these equivalent values. As an example of the use of these equivalent values, let's solve the following exercise. A debt of $5,500 is due in 27 months. Its money is worth 8.4% compounded quarterly. What is the equivalent payment 36 months from now? So what we have, what we know that the interest is 8.4%. So we are going to type here R equal 8.4%. And it's compounded quarterly. So we are going to be counting quarters. So I'm going to type that there are 4 compound periods per year. So M equal 4. So if we think in the time as a line, now will be a point in this line. For example, this point at the beginning of the line. And they tell me that a debt of 5,500 is due in 27 months. So there will be 5,500 that is due that day 27 months from now. And the question is, what is the equivalent payment 36 months from now? So there will be a payment here 36 months from now. Let's type here 36 months. And we need to find what will be the value of this x. Obviously, for solving this problem, we need to choose a focal date. We need to find a focal date. And I told you before that one of these two dates will be the best way to solve it. So use as a focal date the date in which one of the amounts are due. You will notice that will be easier to work if you choose as a focal date the date in which one of the amount that you don't know is going to happen. And this is, in this problem, there is only one amount that you don't know. What is the equivalent payment 36 months from now? So I'm going to choose this point as a focal date. So we need to compute the future value because we need to move from here to here forward in time. And to compute the future value, we need to know how long is the time between the time this 5,500 is due and the focal date. So all this time here, between these two moments. So there will be, there are 27 months from now to this, there are 36 months from now to the focal date. So 36 minus 27, give me this time here, it will be 9 months. There are 9 months, and because we need to know how many compound periods in the formula of the future value, we need to find how many compound periods in 9 months, how many quarters in 9 months. Every quarter is 3 months, by the way. So there are 3 quarters, so n equal 3. From here to here, actually there are 3 quarters. So the formula for this 5,500 will be the formula of future value but using n equal 3. So let's type this because these two amounts needs to be equivalent, then x will be equal, needs to be equal to the future value of this 5500. So x equal 5500, open bracket, 1 plus 0.084 divided by 4, cross bracket to the power 3 because n equal 3 and will be positive 3. So use your calculator for doing that. 5500 open bracket 1 plus 0.084 divided by 4 to cross the bracket and to the power 3. I'm using this sharp 520. I press enter and the answer is 5,853.83. So a payment of 50,853.83 at 30 months is equivalent to a payment of 5,500 at 27 months. If money, of course, is worth 8.4 compounded quarterly. What is the equivalent payment 15 months from now? Not 36 months as we analyzed first in the question A, but 15 months from now. So let's see in a point in time like here. So what will be this equivalent amount that happens just 15 months between now and this step? That's happening 15 months from now. So in this case, again, I choose the focal date, this date, and to compute the value of this x, I don't need to do anything because the value of the x is x. It's happening in the focal date. But for the value of the 5500, I will need to move backward in time, 12 months. Yeah? So it will be moving this backward 12 months, and 12 months is actually 4 quarters. We need to count quarters. This will be, remember, the exponent is the number of quarters in 12 months. So n equal 4, and the value of x will be x equal 5500. Then 1 plus I, because now I'm moving backward in time, I will be using the formula of present value, or better, I will be using a negative exponent. So will be open bracket 1 plus 0.084 divided by 4, but now to the power negative 4. And that, use your calculator again, 5500 open bracket 1 plus 0.084 divided by 4, cross bracket to the power negative 4, press enter, and you get 5,061.27. And this will be the equivalent value of this 5,500 15 months from now. So a payment of 5,061.27 at 15 months is equivalent to a payment of 5,500 at 27 months. Its money is worth 8.4% compounded quarterly. Okay, with this exercise, I finished my explanation of equivalent values, but I will be giving you some videos in which I show you how to solve some other application problems in which equivalent values are involved. Thank you.